should be. So welcome everyone. It's a pleasure to have you on this webinar, which is promoted by the Pulitzer Center in partnership with Cambridge Digital Humanities, Watershed Investigations in the Earth Genome. My name is Gustavo Faleiros. I'm the Director of Environmental Investigations for the Pulitzer Center. I'm speaking from São Paulo, Brazil. And I have today with me wonderful panelists speaking from different parts of the world. And as I can see in our chat, we have a diverse group of attendees as well. I want to thank you all again for being part of this session. So today, as you know, we'll discuss what we're calling like the geo AI, or like the geographical data or geospatial analytical aspect of the artificial intelligence technology. We'll look at some examples. We'll look at some conceptual issues of these applications. As an introduction for this event, I want to tell you really briefly about this partnership that I mentioned. This group, which is formed by the Pulitzer Center, CDH, Earth Genome, and Watershed Investigation, was convened under a program that is called the Accelerate Program for Scientific Discovery at the University of Cambridge. And this program has allowed us to review some of these applications of artificial intelligence on environmental investigations. And what we did with this group was launching some environmental investigations, and you'll hear more about this, but also learn together and share the knowledge that we all have as part of this program in an event that's called the Data School, that is coordinated by CDH and happens every semester. So we participated in 2 of these events where we had some classes and share some of the methodologies that we'll see here today. Also, this collaboration has allowed us to embrace with great enthusiasm some of this technology, and that help us to explore new investigations and find leads for new environmental investigations, leads that have generated stories to be published in Cambodia, United Kingdom, and Uganda. But at the same time that we, as I said, like we embrace with enthusiasm this collaboration and exploring these technologies, we also are working together to understand the limitations of these applications. So looking at with a critical view and finding, trying to find out what are the technical gaps, and also having discussions and about our concerns on ethical. Any ethical concerns of the applications of these technologies in the fields. And this brings a lot of questions related to environmental journalism, investigative journalism, and how to connect these technologies with the work that we are doing in the field. As a final word for contributing to the framing of this webinar, I should mention that we see a lot of discussions and like concerns about the large language models. We see how society and several sectors have embraced the use of technologies like ChatGPT or Gemini, and how this is helping several sectors. We feel that there's less discussion still going on around, these applications related to environmental issues and geographical data, as satellite imagery or other kinds of geographical data. And as I said, like there's a big potential that we can see as these technologies advance for improving issues like rapid response for extreme events and climate events, also big data crunching for understanding trends on environmental damage and also climate change. So our role here is really to understand how this can scale the work that we're doing as researchers, journalists, and activists, but also having a critical view, as I mentioned before. So let's start with not further ado. We'll have each one of the speakers presenting for around 15 minutes, and then we'll open to questions. I'll start with Anne Alexander, who is a researcher at Cambridge Digital Humanities and was one of the the lead figures on these collaborations. Anne, the floor is yours.
Thanks very much. I'm just going to share my screen. Right. So thanks very much, Gustavo. And I also want to say by thanking all of the collaborators who were involved with this project over the last couple of years. As Gustavo mentioned, I'm a researcher and I also teach for Cambridge Digital Humanities. And I'm also working as a journalist myself as well. What I focus on in my teaching is critical approaches to understanding machine learning systems and AI. And essentially, what I'm going to do in this beginning of the presentation is to go through some conceptual foundations of foundation models in particular, which then will be about a basis for Ed, who's going to come next and talk through the particular version of a foundation, AI foundation model, a geospatial model that we used in our investigations. I think one of the things I would very much emphasize here is that when you're in a context where AI is being endlessly promoted as a kind of magic tool, it's always a good idea to start with an extremely skeptical and critical perspective. I often start with this kind of approach. No, it's not a brain. It's not even a brain with blue lights in it. And this is definitely marketing hype. So that might seem obvious, and I'm sure that many people here don't need to have me tell you that. But at a moment when large AI corporations look set to potentially cause a very large financial crash through the overvaluation of their companies, it's also incredibly important to sort out marketing and hype from actual scientific results and from the impact that these tools can have. The other point that I think we all definitely came away from the project with was that using AI tools on their own or as a substitute for journalists, editors, researchers, expertise was likely to end up with problems. And that, like all sorts of sources, AI tools need to be triangulated with others and looked at from a variety of perspectives. So, but what I wanted to start with really is actually just some very basic definitions. And I apologize to anyone who this is perhaps a little basic for, but the getting behind the kind of marketing speak is quite important. And at the root of AI systems, including the ones that we used in our project, are actually relatively simple concepts. Artificial intelligence tools that we see used in commercial settings today, the current paradigm which dominates how they're produced is based on using statistics to help complete classification tasks. Here's a couple of ways of thinking about classification tasks and AI. One is the idea of the imitation game, which you might be familiar with from the film of the same name, which starred Benedict Cumberbatch. But it's an idea that was proposed by Alan Turing in his work on what he called learning machines in 1949. The goal of the program, goal of his, that he'd set himself was to write a computer program which produced outputs which a human viewer couldn't distinguish from outputs. In the case of Turing's original case study, this was texts directly authored by another human. He also came up with a very important concept of the idea that the system would essentially learn from itself. So that's one form of a classification task, where what you're trying to do is to produce something that a human looking at it can't tell whether that was written by the program or was typed in directly to the computer by another human. There's another sort of classification task, though, that is essential to understanding what's happening in AI systems, which is a pattern masking task, pattern matching task, where the goal is to make classifications based on mathematical measures of similarity. And I'm going to illustrate this in a minute, because this helps actually to put into context what the geospatial models that we're looking at are doing when they're classifying images. And Ed will go into more detail about how this works in Earth Index, which is the system that we were using. Here's just a very quick recap on some important terminology. When we talk about an AI model, it's a set of mathematical descriptions of relationships between different elements in a data set. So it could be a collection of texts or images, or it could be sounds, could be audio, could be anything really, which can be used to make predictions in order to complete the second type of classification task I just mentioned, using different data, i.e. the model is able to predict how to categorize something in data that hasn't been shown to it before, based on the predictions using the so-called training data. Training data that's used to create the model obviously will play a critical role in determining the content of those predictions. An example would be if you only see pictures of men carrying out a particular task, then the model would be likely to predict that a picture of a woman carrying out the task wouldn't fit into that category. For the past couple of decades, the general trend in commercial AI applications has been to include larger and more varied data sets into this training process, with the aim of being able to carry out a much wider range of tasks rather than being specialized on a particular task. And these models are sometimes referred to as foundation or frontier models. And this is a graph that has been produced using some data from Epoch AI, who collate a lot of information about AI systems. You can see clustered towards the top corner of the screen how industry models with up to trillions of parameters, which are the variables in the AI system, where those values are adjusted during training to establish how the model works. You can see the predominance of very, very large models and ones that are produced in industrial settings by large companies rather than in academic settings, starting to predominate. I want to talk a little bit now about a question of how you searching images, because tools which mathematically find mathematically similar images within large data sets can be extremely useful, and we have demonstrated in our project that it was possible to search through large amounts of satellite imagery to find instances of images that suggested changes taking place in the landscape. It's particularly useful as a way to narrow down searches where there are too many images for human eyes to look through one by one. In a very crude way, the underlying methods for this process are quite similar, regardless of whether the images are a collection of photographs, satellite images, or any other kind of, or maps, for example, another kind of image. But it is really important to be aware of technical limitations and sources of bias. So, for example, current research suggests that vision transformer models, similar to the ones that we used in our case studies in the project, may give different levels of accuracy and detection depending on the color of the pixels that they're sorting. And this is, I think, important to also take up with a critical perspective, because I think these days there is a good deal more understanding that social bias may come into the way that, for example, image classifiers work, depending on the training data or the labeling that was used, or the model itself. But when you're talking about sorting out images from satellite parts of satellite imagery, it's harder sometimes to conceptualize where biases can creep in, or how different models can give different results. So I want to illustrate this in a very simplistic way to try and give an idea of the things that you would need to look out for to ask questions about the accuracy of particular models. So this is an image from a collection which it's of architectural details of buildings in southeastern Turkey that is on, it's part of Cambridge University collections. It's called the Fowden collection. I ran this experiment when I was teaching a few years ago. So here's an image, which one, and I'm going to show two images. Which one is the most similar to that? Is it A or B? So most people, I think, would probably have said that A is more similar. it's both an arch and an arch. I certainly would not have picked out B as being similar to the first image. However, actually both could be considered similar depending on the machine learning model that you use to sort the images. In the first case, actually the image of the man with the dark blue robe came out as being more similar to the arch than an actual arch picture. The difference was not in the training data, because in this particular case, both of them were trained on exactly the same training data set. It was a data set called ImageNet, but they used different models. One was the VGG16 model, which was produced by researchers at the University of Oxford. The second one was Inception 3, which I think was a team from Google. This is an example of how it's likely to be an example of how the weighting in the model, whether probably edges of things or colors, were given more importance in the ordering of the results. In addition to questions about how the model is constructed, you also have to remember that models, machine learning models, are produced through a process of abstraction, and that's abstraction meant in the sense of removing information to make a much simpler version in order to make something useful. This is a well-known aphorism which is often used by data scientists, the idea that the map is not the territory. Obviously maps, which are very simplified, can play a crucial role in helping you find things quickly. This is a very famous map. It's the London Underground map, which is obviously highly simplified and is not actually that much use if you want to walk between the stations in the middle of the map, because it fundamentally distorts the distances between them. This is a version of the map that was made by London Underground, which is more accurate in terms of the distance between the stations and the relationships, the spatial relationships between them. But of course, it has nothing like the level of detail as a satellite image. And it's extremely important to remember that satellite images are themselves a type of map and still not the territory that you're trying to explore. So to finish up, I just thought I would bring a few kind of bullet points, if you like, about using AI critically in remote sensing investigations. One of the things I think will come through from what the rest of the panelists say is that triangulation across different types of sources is essential. Especially if you are using a service with a variety of foundation models working in concert. One of the trends that I've observed is for large companies like Amazon and Google are developing services in this area where they are potentially going to be offering geo-foundation models for geospatial reasoning, but alongside, for example, large language models and alongside models about population data or demographic data, weather data, and so on. Text-based and multimodal models, so models that are generate text or generate images, are media products, and they are edited by people who make subjective judgments about what to include and exclude, just as they would when producing a documentary film or a newspaper. So, you can think about types of sources, both in terms of the types of data involved, but also in terms of, for example, the editorial line or the political perspective embodied in the people who produce those sources. I would say that triangulation across different social and political and physical perspectives is essential, or you will miss crucial aspects of the story. So this could be the difference that it makes to be able to see something from top down, from the eyes and as our eyes in the sky, versus what the perspective you literally get on the ground. One of the journalists that we worked with, Anton Delgado, discovered this when he went to one of the remote villages where we were looking for mining operations in Cambodia, and discovered the miners had hidden the mine underneath their house, which was actually not visible from the impact on the forest. Another point is who takes responsibility for expert views if you're getting those through an automated service. This is where I'd come back to OpenAI's hype about PhD level expertise. You're not getting PhD level expertise, because if you have gained a PhD and you work as an expert, then you also should have been trained to know your limitations, and you should be trained to be accountable for what you say, which is not the case with an automated system. An expert you can question directly and quote by name can be held accountable for what they say. The final point, which I think is actually extremely important, particularly in relation to environmental reporting, is that the climate impact and the ecological impact of using foundation models and anything that is produced through these incredibly energy hungry and water intense use of factories has a huge effect on the climate. It might be that actually it's much more proportionate and justifiable to phone up an expert in your local university and ask them, rather than to use a foundation model to tell you something approximating the same answer. So I'll now hand over to Ed, who's going to introduce us to the next part of the session.
Thanks, Ed. And while Ed gets ready, I just want to do like thanks for your presentation. Almost awesome points about the bias and the importance of doing the triangulation. And I'm pretty sure we'll have more time to discuss. Just want to do 2 housekeeping announcements here. One is that you already can start putting your questions at the Q&A button here, like the tool that is on the toolbar on the bottom of your screen. If there's any clarification needed by one of the presenters, we are open to ask your questions straight away, but most of the questions will be curated by the end of the session, but please start putting your questions there. The other thing that I forgot to mention in the beginning is that we had a last minute change in the program, and one of our participants, Rachel from Watershed Investigations, won't be able to join us today. So, but we'll have enough time to cover the topic with our presenters here. So Edward Boyda, data scientist from Earth Genome, has been collaborating with several journalists and activists on using some of these models and methodologies on investigations. Tell us everything, Ed. You have to just unmute. Go back to Zoom on the...
Thank you. I've already got myself confused with the buttons on the Zoom call. Thank you, Gustavo, and thank you, Anne. I really appreciate getting to follow your the context that you created here and speak within it. So I am coming here from Earth Genome. We're an environmental nonprofit based in California, and one of our sort of main reasons for being is to try to make geospatial data useful in the world, and particularly with journalists and a lot of other NGOs that do environmental advocacy and reporting. So, and what I'm going to describe today is, very much fits into that context. And I think what I'm going to describe is our attempts really to not to create geospatial foundation models, but to figure out ways to make them useful. And in a lot of cases, this is like sourcing of leads, journalists sort of sculpting or planning out investigations, and in some cases, building data sets that then helped inform reporting directly. So I'm going to try to sort of first kind of give some general description and then move on to some applications where we have managed to make make good journalism out of data from geospatial foundation models. Sorry, let me see. So I'm a physicist by background, but I've had the pleasure and fortune of working with journalists since 2018 in this context with Earth Genome. And just to give my own kind of context, as my personal context, just I've seen a lot of change over the years, dating back to 2018. And really, like one of the initial impulses that we started with at that time was using satellite imagery to help inform Earth journalism, and in that case, a lot of it involved humans looking at screens and trying to find things, sifting through satellite imagery. There's this picture here as an example of a student who was in a classroom that was working on a project with us at some point. And one of you see a number of the images here and throughout are about illegal artisanal mining, and particularly illegal artisanal gold mining, which is something that we've been working on in a variety of countries around the world for a long time now. And all these examples are sort of different iterations of that work. At some point, we started training custom machine learning models. Machine learning is maybe like before people started bragging so much about how intelligent the machines were, we called it machine learning. And so it's like, but really it's like a difference of degree, not of kind. But we, starting around 2021, trained models just to do this specific classification task, like Anne described, of, is this little window on Earth's surface, is it a mine or is it not a mine? And by giving it lots and lots of examples of both cases and having it try to, learn to distinguish between the two. But now there's this new technology in the world of foundation models, which has really allowed us to step away from that sort of like very specialized, labor-intensive, custom kind of work to something that's much more generalizable. Earth observation there's really this is a moment when the resources are much richer than they have been in the past. And I'm sure all of you noticed that this has now become a fairly standard part of reporting in various contexts, particularly in environmental reporting. I also, just on the positive side, since a lot of the work that I do is reporting on bad things that happen to the planet, environmental crime, it's just really positive to see this shift where climate journalism, which was kind of a novelty in some ways, 2018, it now become like a standard part of reporting in many newsrooms. The other things I want to highlight are just that the accessibility of these tools is really improved in just the last few years, and the ease of use and sort of like speed at which we can iterate things in this new context is really changing. So, okay, so let me just go to, what is a foundation model in this context, in the Earth observation context. So it's a type of AI model, which is called an artificial neural network almost always, and that it's undergone extensive and self-supervised pre-training that makes it adaptable to many different types of tasks. Okay, and I'll try to unpack some of those words in the next slide or two. But here, what that means is that you would give this model a large amount of data about what's happening on the Earth's surface. And that can be like satellite data, but it can also include satellite radar, certain text data, information about different land cover, et cetera. And it depends on, if you're a climate scientist versus maybe like, a person like me working with journalists, what type of, data you might want to input to this, but it can be a big range of data. And what comes out of this when you build this model and then run the model over a data set is you get a vector, what we call embedding, which is basically, it's a string of numbers, but it's the model's mathematical description of what's happening in some little patch of Earth's surface. And that vector embedding is what we work with, this little, on a sort of piece by piece basis across the surface of the Earth. And the effort to build these models is really happening around the world in a variety of different contexts, both in public and private and academic institutions. I mentioned the word self-supervised, and I think it's interesting to try to understand, what has changed from the time when I was working with my colleagues to train just a detector of artisanal gold mining, where we just had to give a lot of labeled data of, is it a mine, is it not a mine? That what has kind of sort of allowed this new generation of foundation models to come about is this concept of learning without labels, because it's so hard to get labeled data. The world is just very rich and full of more things than one can enumerate, really. And so what people figured out was that instead of labeling things, they could do this other, ask the computer to do this other task, which is basically just to learn similarities between objects. And particularly what we do now is you take an image of their surface, or it could be a street photograph, like in this example that I pulled from this PyTorch, which is a toolkit for training these things. And you distort it in various ways, and then you ask the machine to recognize that it's actually the same object. And so if you looked at any little window of pixels, say in this picture on the upper left, like if you looked in the upper left corner, and you notice from scene to scene, those pixels are very different, but the objects in each scene is the same object, right? It's just different views on that object, and forcing the machine to sort of wrestle with the objectness of this, not just sort of the local neighborhood of color and shape, but also the sort of extended structure, eventually teaches it to learn very nuanced, sophisticated representations of what's out there on the surface of the Earth, if you're talking about the geographic context. This is just this is a GitHub page that collects some geospatial foundation models or efforts that are ongoing to build these things. So, and I just present this to give you a sense of how extensive the effort is around the world. This whole discussion is new from maybe 2021, 2022, but what's happening of late is maybe worth highlighting as well. And so this is interesting things from 2025 in this sphere. So increasingly people are turning away from just sort of a foundation model that uses a specific type of satellite imagery to a model that perhaps accepts, a bigger list, like I suggested, maybe satellite imagery and some radar, and maybe also text description of places. And so that will allow you to real versatility. You could use different satellite data than the model was trained on, for instance. It has just a general understanding of kind of objects on the Earth's surface beyond that's particular context. And one thing that I'm excited about going forward is this combination of image and text, so that these models are starting to be able to do the following, where you could enter a text description, and it would be able to sort of map that and interpret that also, in concert with sort of image data, and give essentially allow you to query images using text or vice versa. And so far, this is too limited for like it to be useful to me. A lot of so a lot of what I'm interested in is stuff that's not easily accessible. Like a lot of this training is done using like Wikipedia labels, for instance. And I'm interested in things that maybe are not labeled by Wikipedia that are really in remote parts of the forest, for instance. But I think coming down the line, there will be additional, and novel ways to interact with these models. And then I want to mention that this year there was a release of a foundation model by the DeepMind research part of the Alphabet ecosystem, and released on Google Earth embeddings. And this is really, I've really heard a lot of excitement from people that work in remote sensing field, but haven't been using foundation models because it's a big company. This is available off the shelf now, and I think it will sort of extend use of this significantly in different directions. Okay. So that's about foundation models in general, for geofoundation models. What we do, as I mentioned at the top, is really try to figure out how to make these useful. We don't develop foundation models ourselves, and we have experimented with and used a variety of foundation models for. But what we're really working on is building, interfaces to make these things accessible to more people. And so this tool that we call Earth Index is it's a web interface to interact with the data from a foundation model, and looping under is sort of a quick example of how this tool can be used. And so what you saw at the beginning, well, it'll come back up in just a second, was I was labeling in blue some examples of an artisanal gold mine. Okay, the model has no prior understanding of gold mines in particular, but by nudging it and giving it those few examples in blue, then I can quickly ask it to say, what else is out there that's like these examples in blue? And those are the purple results that are coming back. And then what I'm doing is I'm scrolling around and I'm exploring those results. And here, so this is an example of what I labeled was in Yanomami territory in Brazil. This is an indigenous territory in the north part of the country. And then the predictions showed me the expansion of this mining effort across the border into Venezuela. And that's what we see kind of as I zoom out and then zoom back in over to this new area. Yeah, this is now we're in the Orinoco Valley in Venezuela. And so it's in that sense that this is kind of a search tool. You give it a few examples and it can find many more examples of that kind that have the same signature or structure as they appear in the satellite imagery. So and just to put it in technical terms, what Earth Index is, it's this kind of like idea of how you might use foundation models, but behind it is some infrastructure, not the foundation model, which is open source. The imagery also is open source, but we have to gather that imagery and create a global mosaic of the image, run it through the model over the whole, Earth. And then load it into a database so that when the user goes in and clicks on a space, then there's some way of searching that huge database of embedding vectors to find the things that you're looking for quickly. Okay, I'm actually pretty short on my time here, so I'm just going to go through some use cases very quickly just to give you a sense of what's possible. And I think Federico is going to delve deeper into a different one. So that will mesh nicely. But so we have used it to find airstrips in the rainforest in Peru. This was with some journalists that were interested in reporting on narco trafficking and the impacts on indigenous communities. And I should say that I want to be clear here about sort of like use and limitations. And in this case, I was the one who was steering this tool and making use of it. And it works pretty well for airstrips, which are, here's a picture of an airstrip. But when those strips are in the deep rainforest, and it's pretty hard to use it when you're in an area of deforested, ranch lands or something like that. And so some of this also involved just me validating lots of suggestions from the model, and occasionally finding a good suggestion from the model, and very often not, and then but then using that sort of close looking to find others myself. There's another example on a story about illegal logging in Albania. There's been a total moratorium on logging in that country since 2016, but it turns out that in spite of that moratorium, there's industrial logging going on, and we mapped this out using Earth Index tool, and this is again work that I did. But the signature that I was mapping, you can see kind of in the grid in the center here, was these new logging roads snaking through partially degraded forest. And so by tapping a few of those, again, you can see sort of an example search here on the screen in blue. It helped sort of reveal this bigger pattern of industrial logging that was happening. This is an example on quarries in blanking out, Serbia, Kosovo, Bosnia, and Montenegro. And in this case, it was the journalists at Radio Free Europe who were driving this tool and mapped out a huge number of unlicensed quarries across these countries, and just give you a sense of how they use this and sort of like focused their reporting once they had this information. There's some examples there. This kind of search mode that I've described so far is useful for generating leads and sort of like asking, being curious, asking questions, finding first examples. But it's because of the way it functions, it's not good for mapping all instances of a phenomena. And in that case, you need to do another layer of machine learning and data science on top of it, and train additional classifiers using those embeddings from the foundation model as inputs, and some additional labeled data. And so currently this is like the work of a data scientist like me, or we've partnered with other data scientists to use the tool in this mode, but it's something that we're working on making easy enough for others to use. So we've used that to map out dairies and beef feedlots in a project for Climate Trace, which is an effort to map point source CO2 emissions or greenhouse gas emissions around the world from a variety of different sectors. There's a little graphic here showing the sort of the workflow that we use. There's the Earth observation comes in. There's observation data is put through the foundation model, and then there's an additional classifier that's trained with some human supervision and validation to make these detections. And we've been able to use it at scale around the world and map out tens of thousands of these facilities on several different continents. And then finally, back to gold mining. This is recent work that just came out a week or two ago with Forbidden Stories, who I'm sure you all know. Their sort of modus operandi is when journalists have been faced threats or attacks, they try to fill the void to make sure that those stories still get told. And this has been the case in Ghana of late, that there have been a number of attacks on journalists. And this is interesting because just in the context of how to use this tool, because the journalists started really doing a wonderful job of mapping out the mining using just this search tool, and got to a total of 10,000 different patches where they knew that mines were, but it still was like just a small fraction of the whole. It's just an immense destruction that's been sort of perpetrated on the landscape over the last few years. And the actual number is closer to 70,000. And so at that point, I stepped in and helped them and sort of switched modes from the sort of search mode to this, more machine learning mode, and finished mapping out the rest of those mines with them. So I stopped there. Stop with this sort of closing thought. This is my younger kid in what used to be our home in Sápmi, or the far north of Norway. I'm really AI is in my world is not magic, but it has been useful to help start and kick off good journalistic investigations and into what's happening on the planet, and that's really what drives me. And thank you for having me here today.
Thank you once again for your presentation. Fascinating. Thank you for all the insights. And I think you also bring in this perspective that Anne also brought to us, the importance of having, like this triangulation, if you like, where some critical view, a combination of layers, as you mentioned. One thing would not be enough to give, take everything into account, like the complexities of the territory, of the Earth system. So I think this is why we are here, like journalists, researchers, activists, as I can see in the list of attendees. Thank you so much. I was wondering if it would be okay for us to share the link of Earth Index and invite people to also submit requests for early adopters. It's something that you'll be considering, right?
Absolutely. Yeah, we welcome requests from journalists. And I'll try to, I can share the link in the chat here, but also, if we share out transcript or anything after the talk, we'll try to get it in there.
And I'm gonna bring the questions later at the end. I'm seeing they're starting to come here. I think we'll have enough time for covering all of them. But thank you, and here's the invitation for you all to explore Earth Index. And I'll talk about more opportunities that will come out of this webinar as well. Keep the questions coming. I'll invite my colleague, Federico, who is data specialist of the data and research team of the Pulitzer Center. Federico is working with us for more than 2 years now, and has been involved in an awesome project that was part of the data school, the partnership that we have with Cambridge Digital Humanities, that used Earth Index to find out some of these leads for investigation. So he will tell us how was this process. Welcome, Federico.
Hi, Gustavo. Thank you. Just to check, can you see my screen with the slides?
Yes, you just need to put full screen if you.
Cool, perfect. Okay. Hi, everyone. Thank you for coming today. I'm Fede Acosta-Rainis. I'm a data journalist at the Pulitzer Center. I work as part of the data and research team. Today, I walk you through how we have used AI and satellite images to support an ongoing investigation into gold mining in Cambodia. I try to focus on the workflow and how it connects to field reporting, right? And I'll talk also about some of its limitations. This work is collaborative with the Cambridge University, Earth Genome, the Pulitzer Center, and journalist Anton Delgado, which is a rainforest investigation fellow. This story hasn't been published yet, so I'll talk in general, but won't be able to share specific names of location. So sorry about that. So just to give you a context about this story, in recent years, Cambodia has seen a gold mining boom. Long-standing artisanal mine mixed with some newer industrial mining operation. It's a country where the public data about this concession is not clear or available, and we know that also the environmental impact assessment aren't easily accessible. There's not much transparency, but we know that these kind of things happening brings, for experience with our investigation, brings more problems like land grabbing, corruption, and impacted communities. So we have these two goals to make a rough map of the artisanal and the industrial gold mining in Cambodia, just to have a national scale picture, and then get some leads, some actionable leads and locations for field work for Anton, the reporter, to go and check. You already heard what foundational models are and how they work, thanks to Anne and Edward. I'll try to stay practical. So the idea is to show a case study. How can you use this? How this kind of tool helps us to start from the pixels, from the satellite images, and move to the ground, to people, right? While also being explicit about the uncertainty and limitations that they have. So basically, as I was saying, how we can connect this tool with the fieldwork. I'll talk about Cambodia, but we also are using this approach for other ongoing investigations, to find flower farms in Uganda, and we also are using this to map gold mines in Central African Republic. So first, why we want to use machine learning plus remote sensing? Basically, scale and risk. I would say Cambodia, it's a very big country, more than 190,000 square kilometers. So if we want to map the artisanal mines or the mines in general, it's kind of a needle in a haystack problem, right? We can go looking at the whole map by ourselves, one by one. Also, there are irregular activities here, which I was saying there is no clear data available. But also some of these areas, when these mines are located, are sensitive or remote. So that's where satellites can help us to reduce exposure, at least at the beginning, to this, the pre-reporting. And we already test this in another investigation. Maybe I suggest you to take a look later. Amazon Mining Watch, this approach of using this kind of system. But something that for me is very important to make clear from the beginning is like AI doesn't replace reporting, just empower it, right? So our aim is not to find every mine, but to point the reporter to some promising places where he can find mines and testimonies, etc. So for this, we develop a 6-step methodology, build a seed data set with mines, use machine learning, in this case, Earth Index, to scale it, to extend the scale, do a lot of manual validation. That's we spend a lot of time looking at the result from Earth Index to identify some potential interesting areas. Then choose the area of interest. Do the field work. That's the reporting, going into the field, doing the shoe-leather traditional journalistic work, and then iterate. Come back with gram truth and iterate to keep improving all our process. I will go one by one to show you how. So basically, the first step is data journalists always want to start with a data set. We begin by trying to understand how artisanal mines look from space, like in satellite images. We know are these kind of clusters of irregular pits, muddy, surrounded with water in different colors, from brown to emerald. And we wanted to know where there were some of these in Cambodia, to show them to the model, right? So to find these initial ones, we combine open sources. We did OSINT and looking a lot offline, looking into news, official databases, NGO reports, social media, to try to identify where we can find some of these mines and mark them. And then we mapped them using Google Earth Pro, tools like Google Earth Pro and QGIS, right? So this seed set is how we teach by example. We use this, and then we show this to the model to discover more finding. The next step is then, as I was saying, scale, define our findings with Earth Index. Ed already showed this in action. Basically, we label a few examples of these mines that we found, and then after tagging them, we run the prediction to find similar ones nationwide, right? On the right hand, I cut the image in half, sorry, because I can't show all the locations, but basically we are getting like around 500 of similar images all around the country, and start looking into those lists. This quickly expands our coverage, right? Because allow us to understand where are these like the hotspots located without the without needing to go one by one look at all the country in the map for hours. It's important that one very interesting thing that you can do with Earth Index is to mark some positive and negative. So as you can mark in the left side, I'm marking some positives, but you can also mark some negatives to tell the model what specifically you are trying not to look for, right? So what you are looking for, and we are trying not to look for, because as we'll see in a minute, things can get complicated, and there are a lot of false positive and false negatives. So the next step was to export all the findings. You have these options, the option to do this in Earth Index as a GeoJSON file, and we opened that in Google Earth Pro and in QGIS for manual analysis. If you're not familiar with this, these are tools that you can use to manage and use geospatial data, right? The next step was the manual validation. This I think it was of the step where we spend more time, a lot of time actually, because as I think all the both Ed and Anne said this from the beginning, AI help us to guide this reporting. It's not AI automated, but this is AI guided. So we really need to do a lot of manual validation, right? To see if these detections that we got from the model are actually what we are looking for, right? So we use for that, I was saying Google Earth and QGIS, because they offer to audit the detections from Earth Index, because they offer a lot of interesting things like higher resolution imagery. We can look at better images and see if actually they look as gold mines in those images. We can use historical data. We can go through historical time series. We can also use different layers. We can add layers of protected areas to see if there is some potential mining happening inside of a protected area where it shouldn't. We can add, if we have some layers for the concessions of industrial mining, and also add satellite images from other providers. By doing this process, we added some missing mines manually that the model didn't catch, and also try to look for things that the model identified as mining, but they weren't. For instance, sand pits or sand mine, or also rice paddies, rice fields can mimic artisanal mining, are very similar from the top, if you look them from a satellite images, and those are like what we call false positives, right? Things that are identified in the model in the images, but they actually aren't mines. And on the other hand, we can also have like false negatives, right? Because there are some mines that are very small and are not being detected by the model. There are differences by region. Sometimes in the Amazon, it's very easy, as Ed was saying, to spot, because basically you have primary forest, and in the middle of the primary forest, gold mining. So it's like you have or forest or mining. In Cambodia, the territory is very different. Sometimes the gold mines are very close to human settlements or places where there is human activity. So it's more difficult to actually see and check if these are or find these places, right? So there you have a lot of false negative too. Some other limits that you have when you use this kind of approach and technology is, as I was saying, the resolution. Earth Index runs on open source imagery, which is Sentinel-2. It's a satellite from the European Space Union, where the resolution is 10 meters per pixel. I mean, that's good for things that are big, but you can imagine that it means that one pixel it's just 10 meter by 10 meters square. So some things are not really being picked up. Also, there is a lot of seasonality in the images, right? So it means that if you look at a place with the satellite images in the winter, it's not the same that if you look at during the summer, because of crops, because it's how the landscape change. So that's another limitation. Earth Index has a year of data, that it's only one, let's say it's one image for the whole year, right? So you can see as for the moment, like different times through the year. And also, I was saying there is a lot of noise that comes from human activity, right? So maybe there are, I don't know, pits for buildings, pits for other kind of stuff that in the straddle image might look as, or the model might detect as mines, but are something very different. So it's very important to be skeptical. This is an A 101 for journalists, but I want to say this again. The model suggests things, but we need to confirm, right? So we should treat every detection as an hypothesis to verify, right? Not like a fact to publish. This is very important to have in mind. Okay, so these are a couple of examples. For example, I was talking about false positives. On your left hand, you can see a sand mine that has been picked by the model because it looks similar to a gold mine, but it's actually a false positive. It's not a gold mine. And on the right hand, you can see in red the detections by the model. And you can see that I manually tag in blue some squares where there are actually gold mines, but haven't been detected by the algorithm, right? So you can have, and you can see in the next slide, how do they look in close, right? The same places. This is from satellite images, and how do they look when these are drone images by Anton when he actually went to these places, right? So they are very different. Okay, so the next step after we do manual validation is to choose our area of interest. So as we start validating some of these findings, as we start, there are some patterns. We find some clusters of mining with some potential cluster of mining, some corridors, some places, some hotspots that might be interested. But instead of publishing a precise map, which we have, but I can't show it today for confidentiality, we reduce this to a short list of area of interest where field reporting has the highest value, where basically we want Anton to visit and check, right, these places. So how to decide this? We have this Anton brought this hypothesis that artisanal mining is starting to convert into industrial mining. So we were trying to find a place where can we test this hypothesis. Is there, if you look in historical images, can we see that this is becoming an industrial mine? But that's not the only criteria. Also, we are looking for visible environmental impact, so maybe deforestations around this place, new roads being built, I don't know, water diversion. Is there any recent mining activity? Are there many mines in the area? Are there nearby villages that could mean a health issue? And also, as I was saying before, we are really looking into mining activities into protected areas. So with this, so far it's everything I have been talking so far is pre-reporting, and now it's the time to go to the field, right? So that this is when the story comes alive on the ground. So it's very important to prepare this very thoroughly with a risk assessment. As you can see on the right hand, on the top upper right hand, you can see we put together a reporting plan, like with specific coordinates and places to visit, to understand plan offline routes, because these were very remote areas where Anton was planning to go, checking where there were possible specific waypoints. We know the government was there, we know armed groups were there, trying to find and map these potential artisanal mines for the visit, potential industrial sites, streams to check, etc. Of course, having some local contacts. And during the field trip, the very interesting thing is like Anton was able to gather, he did this for 3 different locations. He was able to gather testimonies, like first-hand testimony from affected people, from miners. He took a lot of videos. All the images that you have I'm showing so far are from him. Apart from being an amazing reporter, it's an amazing photographer. And also, yeah, he brought videos, pictures that crucially were very useful to actually confirm or verify our satellite-based assumptions, right? So some candidates turns to be sand mine, turned out to be sand mines, which is not a failure because that can open new leads for other kind of stories. And others were actually, yes, this is artisanal mining, and I found much more that we were thinking. Something that is very important also to take into account in the going to the field part is all the ethical consideration. You need to protect identities, especially if there are, I don't know, minors in place. Anton found a lot of like child minors. And also, of course, you are investigating activities that might be irregular, and you need to make sure that you don't expose these people or these communities. What will be the impact for this community? You are just a reporter. You are trying to understand what's happening. Okay, of course, never put in the source asterisk. So these are some images from Anton's trip. This is of course, industrial mining, some artisanal gold mining, more artisanal gold mining. He talked with different miners doing manual work. Yeah, and yeah, was a very, very, very interesting reporting that hopefully will be soon published. So just to finalize, this is what allow us to get some ground truth, right? All what we did before was some pre-reporting just to make sure that Anton was going to the right place in the right moment. But without ground truth, you can't do anything, right? So this is basically our workflow. You start with your data set, do all the steps that I explained before, and when you get the ground truth, you iterate, right? And you now have a better understanding on how the place is. We can refine the labels that we look into in the Earth Index. We can fine-tune the thresholds for detections. We can adjust what similar means in different parts of Cambodia and pick a better area of interest for next trip. So let's say that each iteration makes the model plus human team a little sharper and better, and allow us to do better reporting. As I was saying, we did this three times with Anton for every new location he wanted to visit. And I really think that this loop is where the foundation model plus the human team working together shine. Thank you.
Thank you so much, Federico. Thanks for being so detailed on each step that we took for making this investigation. Very insightful. And thanks for reinforcing the message, which I think is the main message of this webinar so far, which is we need to take the ethical considerations into account, to combine methodologies, to test and iterate everything that we do with these technologies. We have a good number of questions. We'll have roughly 20 minutes to go over them. I have some ideas on how to organize the questions. So we had one initial question that I thought Fernanda made some points for Muhammad Khan, but I think it's a good question to ask for Anne as a provocation, and then combine it with other questions that we have here. So Muhammad Anne is asking, like, it's even ethical to cover the environment using satellite image. So this is one question that I would like to hear your comment, which combines with two other questions that I'm seeing here. One by Alexander. Let me see if that's the one. Yeah, Alexander Maniziev, if you allow me, Alexander. If there's any legal implications we should take into account when doing this investigation. So I throw this to you as well, and together with the ethical considerations of doing investigation with satellite imagery. And then in the same stream to add, Tarini, if I understood correctly, Tarini, your question is asking if Earth Index has some ways of, I think, bringing this ethical consideration. So the example that she's asking is about when you are investigating deforestation or forest crimes in India, for example. Sometimes, like communities and the weakest parts of these chains are blamed to commit the environmental crime, while like the data cannot distinguish who are the culprits. So is there any way of these models can actually find the environmental crime without blaming wrongly the locals and the individuals that are working in the supply chains? So some questions for reflections. Should we start with you, Anne?
Yes, thanks. I think the question about ethics is a very important one, and I guess it depends on what you think of as ethical practice, whether you're a journalist or a researcher. I mean, is it that you intend to, kind of like in a medical ethics model, you might think about doing no harm, but if you're thinking about exposing wrongdoing or enabling accountability for wrongdoing and harm that is done to others, so that's the fundamental question you need to ask yourself. Does the perspective that you use of a satellite view, where does it fit in that in your ethical practice, and how does it enable ethical agency either for you or other people? Because you can have, as was hinted at by one of the other questions, you could have a satellite perspective or any data-driven approach to making maps or exposing harms that are being done can also encourage further harms, because if you don't take into account power imbalances, then you may be actually creating a map that will enable other people to go and find more gold in these areas of remote forest, for example, or expose the weakest people who are part of this kind of harm to the environment, but are also being harmed themselves by the state or by armed groups and so on and so forth. So I think the answer is yes, it can be ethical, but you'd have to consider it in a broader question. In terms of legal implications, then yes, also there could be legal implications depending on the context. One would be, as if again was hinted at by one of the other questions, if you misidentified and mislabeled something by contextualizing it in a way that suggested that wrongdoing was taking place where you didn't have any proof of that, or you had got something wrong, then that could expose you to legal consequences. But there are also areas where, if you're using, one of the things about using remote sensing investigations is that it gives you a tremendously powerful perspective, which is one that's often been previously associated with either very powerful companies or states or militaries, and can essentially be a kind of considered a dual use technology. It's something that could be used for military purposes or for spying. So again, you have to think about whether the investigation that you are carrying out could be seen in that light, and might put not necessarily you yourself, but potentially people you collaborate with, or people who you might be identified as having talked to on the ground at risk of harm. And then that goes back to the question around power imbalances and which side you're standing on. Thanks.
Super interesting. Thanks, Anne. Ed, on.
Yeah, I could jump in here with some thoughts. I mean, this is like an incredibly complex conversation that we could have a whole discussion about, and I think like let's think. I think first of all that largely when I think about using satellite imagery or satellite imagery plus artificial intelligence in doing environmental investigation, I lean on the same principles of journalistic ethics that would apply to many other cases, like report, seek truth, minimize harm, but there are real sort of nuances and complexities here that need to be viewed through that lens, so I mean, even just to turn specifically to this topic of illegal artisanal mining, this is a complex topic. So certainly the mining levels great harm on the environment and great harm on communities that are near to where it's happening, and very often that's indigenous communities, because a lot of this is taking place in areas of for instance, remote areas of the Amazon rainforest. And at the same time, those are people that the miners themselves often are pushed into that line of work by being in economic straits and various other like large systemic forces that are sort of driving this big pattern of sort of seeking and exploitation of natural resources. And then there's also another layer of this, is that there's a lot of there's cartel and organized crime and drug trafficking activity, money laundering that's implicated. So it's a big topic. Regarding indigenous communities in particular, I have a couple maybe interesting things to say here. So first of all, like personally, and then also institutionally at Genome, we got into this looking into artisanal mining by request of the Hutukaru Yanomami Association, which is a Yanomami advocacy org, through their partner Survival International, who wanted to have international attention brought to this invasion of miners at the time. 6 years ago, there was like 20,000 miners coming from outside and operating in Yanomami territory, and they have continued to use technology themselves, satellite imagery, in partnership with supporting NGOs, of which we could count ourselves, to build data and take it and advocate for enforcement to the regional government. And we actually have a number of ongoing partnerships with either indigenous communities or indigenous supporting orgs to do similar work. So there's definitely interest coming from those communities to use these kind of resources to protect their communities. At the same time, I know of other examples, like a journalist that I'm working with is exploring a case where basically some data was used that sloppily that purported to map mining, but also map some indigenous small scale agriculture, and swept it all up in one bag and kind of created some some problem for the communities there to pursue their sort of normal and traditional livelihood and agricultural practices. So I think the bottom line is that any kind of data like this needs to be used responsibly. Certainly, if I were going to, find data with either by satellite or satellite plus AI, and sort of, make a claim about who, what was happening in a particular territory, I would find multiple ways, or want to find multiple ways to validate that data and really understand what's going on by the traditional practices of talking to people and interviewing and pulling complementary data sources and doing all that journalistic work.
Thank you, Ed. And I think your last points cover partially what Ola Lengan it's asking about, like how to take into account some of the deep indigenous knowledge and complex historical legacies into account. We have 10 extra minutes. I just want to cluster some questions. So there's 2 questions, one by Adam, another one by Eden, that ask, what is the difference then of using something like Earth Index and, I'm sorry, not by Eden, this one is by Adam, and there was another person asking the same question about what is the difference then of using Earth Index and traditional GIS systems, like QGIS and Esri. I'll ask maybe Federico and Ed to make considerations, but we need to be brief to make time for other questions that are still pending here. So
yeah,
the difference.
I can jump in quickly. In fact, I was trying to answer Sultan's question. Yeah, basically AI allows us to start with an initial data set of places that we found, and from that data set quickly create a rough mapping or a rough idea of other places that we don't know where the same kind of phenomena that we are looking for happen, right? And we can do that in a very big territory. When you are working in a small territory, you can do it manually and just map by yourself. But as I was showing the example, that allowed us to do the quick rough mapping of all Cambodia. And this is very important, especially in the cases where you don't have there is no public data about this. When you deal like with irregular or illegal activities, I know that Ed, and maybe he can talk more about that. Use this technique to find airstrips connected to illegal mining and narco activity in the Amazon as well. So, but as we said, it's very important to do then, after you have this first idea, do the manual validation and of course the work, the field work.
Yeah, I think I just wanted to put a picture to what Federico said. So this is the Amazon Mining Watch, which I mentioned is kind of our older AI platform for detecting illegal mining in the Amazon basin. In the yellow here are all detections of mine scars. When we were doing this initially, like manually using traditional GIS and satellite imagery, we mapped out this portion of mining, and this is Yanomami territory, and that took just so much work and time, and we also did, well, no, that was already in the AI. So if you want to do it at scale, like at the scale of a continent, understand these bigger patterns, that's when it's useful to automate these things and pull for a tool like AI. And when you don't know where to look, that's another good reason. So like if it's a needle in a haystack type of problem, and you really just the terrain is too big for you to know, and to canvas yourself, then this can be a useful tool.
Thank you. I'll ask one more question to Federico, one more to add, and Mariana, I will leave your question as the last one for Anne to respond about the resources consumed. So for Federico, Roland is asking us, what should be the level of skills journalists require to use these tools? Is it necessary to have advanced coding, command line level, or just an ordinary data journalist would take care of all of this?
Well, depend on what you want to do. The amazing thing about Earth Index is that all the heavy data work has been done initially by Ed's team, and they put together this tool that you can easily use. You can he showed how to do it. You just label a few places and then get a first big full picture. What I suggest, you can do some kind of similar work using Google Earth engine, and for doing something like that, you need to do much more. You need to do no coding and do much more advanced work. But what I would suggest before going to something very complicated, and I'm an ambassador on QGIS. No, for every data journalist, I think it's very important, if you work with environmental stories, every data journalist, or I would say every journalist should have at least a grasp or an idea on how to use like geospatial analysis data tool, at least starting Google Earth, Google Earth Pro, and maybe if you can learn some QGIS, that will be very, very helpful. But with these kind of tools, you can start very easily. And what we always suggest, and this is an example on how this kind of work is done, and we say it from the beginning to the end, this is a collaboration. So always look for experts, talk to people that might be working on the same field as you, but from the other side, like the data scientist or the academic, and making a collaborative work will make the entry point much more easier.
Thank you, Federico. Some technical questions for you, Ed. Eden is asking, what's the smallest object that you can label or found in Earth Index? And then Matthew is asking, once you do the manually tagging, how do you upload the data set? Is a CSV file or any other forms of training the model? Is there a way of you inputting a data set to Earth Index?
Currently, we're using Earth Index is based on this open source data. Sentinel-2 is the name of the satellite. It's run by the European Space Agency, and it has a 10-meter resolution, which means that like all the light in a 10 by 10 meter patch gets, sort of averaged into 1 pixel. So this is good for seeing landscape scale objects, not for seeing, individual bushes. But I think maybe you saw in some of like the pictures, like the logging roads, for instance, in the degraded forest, how that appears in Sentinel imagery. So just roughly speaking, I think things that are like big on the landscape, but in industrial agriculture, quarries, roads and forests, things like that. Sorry, second question, Gustavo, was
how to input data set.
Inputting data. Yeah. So okay. So right now, if you're using the user interface in the search mode, you need to go in and tag objects yourself. You can export data, but not import it. That's something. The mode of beginning to tag things and the ability to upload data is something that we're working on actively, and it will be released in a new version of the tool in the next couple months, something like that. I think like going forward, there's going to be increasingly sophisticated ways of interacting, and potentially down the road, even just like chatting with it or saying, I'd like to find examples of artisanal mining in this area, and it might be able to kind of run with that kind of request. So that's a little bit out there.
Thank you. We're looking forward. So final question, and it's a very good one. Thanks for your patience, Mariana. And this is for you, and about the environmental concerns we should have when deciding to do these investigations. So Mariana is asking us, like, what should be the balance between, doing large requests for this geospatial models and the balance between doing these requests and having an environmental concern about the footprint that AI data centers and systems are creating these days.
Yeah, I think this is a great question, and it's actually quite difficult to answer. I think you should always ask yourself, why am I trying to do this with AI at all? Is it actually necessary to do this? Because one of the things that you'll notice about the way that AI is marketed is that people are using AI to do things that actually they did with other means previously, and that's a deliberate marketing strategy, and it's also deliberate to hide the environmental impacts of it. I can share some links we'll send out an email after the webinar with some details, but there are some good rules of thumb that, for example, climate conscious digital humanities researchers use, which include things like, as I said, don't use AI at all if you don't need to. Don't use it just for fun. Larger and more generalist models don't necessarily result in are almost always much more environmentally costly, but don't necessarily bring better results. And multimodal models are often extremely costly because they do a lot of training and to create this illusion of general, being able to solve any problem, which is actually not necessarily what you need. So those are things that you can do. The other thing that I would say as journalists, what you can do is put pressure on the companies that make these models to be accountable about the amount of energy that they're using, the amount of water that they're using, and the footprint of the pollution that they create. Because until they're put under pressure and exposed for what they do, then they will have no incentive to tell us how much impact those queries have, or why they're steering everyone in this particular direction. So I think there's a job that we can do in holding the industry that makes these models to account.
That's very useful. Thank you, and thank you all for participating. Thanks for the questions of the the attendees and for the comments. We're very happy with the reactions here. Thanks, and Federico and Edward for making part of this webinar. Thanks, Fernanda Bufa, our colleague at Pulitzer, that is running everything on the background. I will paste here, and this is for you who stay to the end, our link for reporting grants and fellowships, the opportunities of the Pulitzer Center. We are basically funding a lot of these investigations with the use of AI or without the use of AI, to be honest, but a lot of, you know, like the accountability also of the AI ecosystem, if you like. We've been recently doing a survey to understand what are the needs for more reporting on data centers. So proposals on that topic will be very much welcome. But also there are possibilities of doing stories and research using AI itself in the process of the methodology. We are looking for proposals like this. And there's all the environmental area of investigations that we, Federico and I, were directly involved and have done some of the work with, also in partnership with and Edward. Rainforests, oceans, to be honest, climate, every single ecosystem is of our interest. So please feel free to reach out and ask questions. But there's a good guide on how to apply to our opportunities here. More webinars will be coming. I'm not sure about this year, but certainly next year we have a big program happening now at the COP30 that's going to happen in Belém. So if any of you are flying to Brazil or in Brazil to attend the UN Summit on Climate, please find us there and attend our events. And also Anne is sharing more about the data schools, this awesome program that we were happy to be part of in the past years. And also I believe Ed already shared more about how to get access to Earth Index as an early adopter. Again, thanks everyone to participate and for the questions. I hope to see you in the next events. Thank you. Have a great week.